Welcome to AutoSense, the world's leading community for ADAS and autonomous vehicle technology development. We create best-in-class events, training, and information for the purpose of connecting the global community of scientists, engineers, and other automotive industry experts. One such expert joining us now is Ridha Ben Mrad, President, CTO, and co-founder of Sheba Microsystems. And Ridha, welcome to AutoSense. Good to see you again, my friend.
Well, it's nice to see you, Carl. Thanks for the opportunity to have Sheba Microsystems.
Indeed. And tell us a little bit about Sheba Microsystems and tell us about some of the work you're doing today in the automotive industry.
Yeah, sure. So Sheba Microsystems is a manufacturer of silicon-based microactuators that are used to move the image sensor die inside automotive cameras to achieve consistent, high-quality imaging from the cameras. So what we do, we move the image sensor along the optical axis to ensure that the camera is consistently in focus. And this is to address issues like, changes in the focus of the camera due to thermal effects, as an example.
And how did the story begin for Sheba Microsystems? Ridha, what was your inspiration for founding the company?
Yeah, so Sheba Microsystems actually emerged as a startup from the University of Toronto about 10 years ago. We are aware of challenges in miniature cameras with regards to autofocus and optical image stabilization. And we pursued the development of microactuators back then to do autofocus and image stabilization, and our technology focused largely on moving the image sensor as opposed to moving the optics, which is largely done in smartphone technology. And I'll explain further. Later on why this is the case. And since then, we have established a number of partnerships. Since we incorporated and we founded the company, we established a number of partnerships in North America, and Europe, and Asia. And we're looking to move basically our technology into the market. We have a number of partners currently that are testing our technology on their vehicles and in their cameras.
Now that we have this history of Sheba and an overview of the work you're doing today, let's take this to the next level. So talk about some of the challenges right now that you are helping to solve in the automotive industry with your solutions.
Yeah, so companies, OEMs currently are continuing to push technology that will enable more autonomous and safety driving functions. Many of them are looking to introduce high resolution imaging to facilitate a number of functions. And current high-end ADAS cameras use 8.3 megapixel image sensors. These cameras are all fixed focus, because they have not been able to find the technology to enable autofocus capability in these cameras. As you know, these cameras do provide unique signals that are essential for safety and that are needed for, to enable a number of functions. However, the cameras operate in an environment where the temperatures varies quite a bit. Typically, in automotive systems, we're looking for stable operation and performance as the temperature varies from minus 40 degrees to 125 degrees. And also in the automotive environment, the cameras are subject to 1G acceleration environment. So, mechanically, they have to be stable too. So all of these constraints in terms of temperature variability and the acceleration environment, the 1G acceleration environment, put many constraints on the design of the cameras, which basically limits the choice of a number of components, etc. So in the future, OEMs are looking to introduce high-resolution cameras to enable more of these autonomous functions. And because they are impacted by temperature, the cameras are impacted by temperatures, they tend to lose their focus. And this is, I mean, especially the case as the pixel size tends to decrease. So as the pixel size decreases, the temperature effects or impact on the distance between the image sensor and the optics becomes more and more important, and to maintain it at all temperatures becomes more and more important. So what we do basically at Sheba is we do move the image sensor along the optical axis to ensure that the camera is always in focus. And currently, as I mentioned, the cameras are fixed focus. As the temperature varies, and also because the image sensor itself does emit quite a bit of heat while in operation, the cameras tend to lose their focus when the temperature exceeds basically 65 degrees, which is a temperature they reach relatively fast because of the heat that's coming out of the image sensor. So all of these basically issues tend to limit quite a bit the design of the cameras. Now, the current size of the pixels that are used in high-end cameras in the automotive systems are 2.1 micrometers. They are expected now to go down to 1.4 micrometers in the next 2 years or so, and then to go down to 0.9 micrometer in size by the year 2030. So this reduction in the pixel size will have significant implications in terms of the changes that the camera will be subject to due to temperature variability. In fact, because of this smaller pixel size, the need to do active athermalization or active compensation of these changes becomes a necessity. And our technology is there to actually do that, to enable that compensation, and to ensure that we can move to smaller pixel size in the future while being able to compensate for temperature effects, so the camera will remain in focus all the time.
We're speaking with Ridha Ben Mrad, President, CTO, and co-founder of Sheba Microsystems. And Ridha, we have been touching on this a little bit, but what other trends do you see in automotive right now that we should be aware of?
Yeah. So, well, in terms of autonomous vehicles, obviously I spoke already about the need for high resolution imaging and how that is essential to enable, more functions, safety and autonomous functions. And we understand from image sensor manufacturers that they are coming out with smaller pixel size sensors in the next couple of years. And but also there is a need to have high performance during low light conditions, which also leads to a shallow depth of focus for the cameras, exactly in the same way as when we shrink the pixel size. So changes in various components due to temperature variability becomes also important for low light conditions, and that puts also many constraints on the design of the camera. So by providing manufacturers and tier one camera makers the ability to do compensation along the optical axis and moving the image sensor is essential, and would enable more or less higher performance also during low light conditions. Not only higher resolution, but also higher performance during low light conditions, so that temperature effects will not reduce the effectiveness of the cameras. And maybe I could add that no technology is available today to compensate for these temperature effects and this variability, and to actually enable the use of higher resolution and smaller pixel size image sensors. people obviously think about smartphone technology, which is use voice coil technology, voice coil motors to move the optics in smartphones to do, I mean, to maintain the image quality and ensure the camera is always in focus. But I mean, such technology is not useful for the automotive environment for a variety of reasons, including the fact that in the case of a smartphone, the optics is relatively light. It's of the order of 150 milligram to 100 milligram. I mean, whereas in an automotive environment, the lenses and the optics is about 6,000 milligrams, so about 30 times as much. So moving, I mean, such a large mass under 1G acceleration condition is quite challenging. And also, like VCM technology is electromagnetic, and therefore it is impacted by temperature and hysteresis. And actually, that will lead to quite a bit of variability, which may exceed the size of a pixel. So the camera may actually be blurry all the time if such technology is used. So what we propose is an electrostatic technology, which is all silicon-based. And it is actually novel that we developed this novel design like a number of years ago, which is a micro actuator technology that's positioned behind the image sensor to move it along the optical axis. And it's a rugged technology that has been demonstrated to be relatively rugged and solid. And it's not impacted by temperature since it is silicon-based. And it has, very nice characteristics in terms of accuracy, in terms of speed of response, in terms of low power requirements. And what we do also is we do direct wire bonding from the imager to the PCB, so that we don't actually impact that path of signals, and that ensures that the signals that are coming from the imager are quite good and they are not impacted by the solution. And we have demonstrated that even though the imager is moving along the optical axis, this wire bonding process is robust and solid, and ensures basically high integrity and reliability of the solution. And in fact, we have shown through prototyping and through extensive testing and sharing with a number of partners that our solution is providing consistent high quality and high resolution imaging from -40 all the way to 125 degrees.
You will be with us for AutoSens USA in Detroit, June 10th through the 12th. And Rita, what are some of the objectives and goals that you have for the AutoSens event for 2025 in June? And then further to that, even after the conference, what are some of your objectives even after we all go home from the Detroit event?
Yeah, so we are looking forward to the Detroit event in June. We're looking to meet a number of our partners. We'll have obviously prototypes at hand. We'll have demonstrators. We'll be showing our technology in terms of performance and how easy it is to integrate. We're looking to talk to our current partners, but also meet more potential partners and for the future, to demonstrate our technology and to discuss how we can address some of their problems. We are making samples available for those that want to test them. We are confident of the quality and of the claims we make regarding the technology. So we are making samples available for those that want to test them, and looking forward to engage more with many partners in Detroit and beyond.
Speaking with Ridha Ben Mrad, President, CTO, and co-founder of Sheba Microsystems, will be with us for AutoSens USA in Detroit. That's June 10th through the 12th, 2025, at the Huntington Place in downtown Detroit. Ridha, always a pleasure to have you with us. Thank you for being with us today, and I look forward to seeing you here real soon in Detroit.
Thank you, Carl. Thank you for the opportunity. All the best.
For more information on Sheba Microsystems And to find out more about our upcoming events, see the links in the description or visit auto-sense.com. That's auto-sense.com. And for more in-depth interviews like this, subscribe to the AutoSense YouTube channel and follow AutoSense on LinkedIn. In Detroit, on behalf of AutoSense, I'm Carl Anthony.